Hi, my name is Jackie. We did biodiesel from algae.
My name is John Mason.
My name is Isi.
Alright, so our project is to try to find the optimal way to produce biodiesel from algae. Basically, our parameters were try to understand algae if it was mixotrophic, heterotrophic, or phototrophic, which is the best. And with all these different parameters. And John, you talk about the parameters.
So when we're growing algae, there's a few different things that we can provide, a few different ways that we can provide energy. The most natural way is through light, through photosynthesis. The secondary way would be through a carbon source like glucose. We could also consider doing a combination of the two, which is useful for this sort of process, because if we grow in the conditions of light, we can get a lot of algae cells. If we grow in dark conditions with glucose or another sugar, then we expect very high oil production, which is useful for our process. So that's one of the design goals that we were going to try to optimize in our senior design project.
I'm going to talk about the mass and energy balance. So we're looking at producing 5% of the total biodiesel production of the nation, and that's about 16,000 gallons of biodiesel, which is enough to drive us from Purdue to San Francisco. But in order to produce this much biodiesel, we need to grow 375 tons of algae, which takes 10 million gallons of media. So really the energy return of this project is very high because we're looking at taking the energy from the sun. So for every 1 energy input, we're looking at getting 3.5 energy output. But at the same time, the mass balance is not looking that good because really to produce 1 liter of biodiesel, we're looking at using 900 liters of water, which is a huge water usage. Although there are ways to actually recycle and reuse the water, but they might not turn out to be very efficient for now.
So at this current state, from our research, we realized that to really make a profit or to develop this and scale this up in these different ways, you had to sell a gallon of biodiesel for $30. But right now, the current cost of biodiesel is basically $4 a gallon. So basically, right now, biodiesel from algae currently needs to have more research done to actually, in order to provide a more profitable or economical place. So some future works are doing genetically engineering our strand. And John, you want to explain a little bit more about that?
Sure. When we're looking at this process, just the main issue is that the algae itself either doesn't produce enough oil or we can't get to that oil easily. We have to break it down and extract it. One idea that at least one company has been playing around with is finding a strain of algae which can actually secrete oil. And this would completely change how this sort of process works. And there are other possibilities for genetic engineering to try to gain better control over metabolism or to increase the oil production.